Hello everyone, it's Brian with another Rocky Linux video. I thought it would be a good idea to explain the file or directory properties and how they dictate access, permission, and ownership within the Linux file system. By understanding these fundamentals, you'll be able to organize your files efficiently and troubleshoot common issues with confidence. I'll give you a fair warning. This video is lecture heavy, but short and very simple. So let's get to the lecture. So if you were to open up your terminal and type in the command ls -l, you get a detailed listing of files and directories in the current directory. Each line in the output represents a file or directory, and the columns represent different properties of these files. Here, we will break down each column. From the output on the right, we can observe 7 attributes listed for each column. They're pretty straightforward, but we're going to tackle each column from left to right. First, file type and permissions. This section reveals the type of file and its corresponding permissions, detailing read, R, write, W, and execute, X, access for the owner, group, and others. We will discuss more about this later in the video. Next, we have number of links. Indicates the count of hard links to the file or directory, signifying additional names referencing the same file within the file system. Then we have owner. Identifies the user who possesses ownership rights over the file or directory. Group specifies the group associated with the file or directory, influencing access permissions for group members. Size reflects the file size in bytes. Date indicates the date and time when the file or directory underwent its last modification. I want to point out that if a file hasn't been modified within the last year or months for Linux, the year of the modification is displayed instead of the time. And finally, we have name, which displays the name of the file or directory itself, facilitating easy identification within the file system. Now that we understand each column, I would like to talk more about the file types and permissions. As you know, this column holds critical details regarding the file type and permissions for each entry, which is essential knowledge. It furnishes insights into whether the entry is a regular file, directory, symbolic link, or another type of special file, along with the permissions dictating access to it. Let's dissect it further. Take a look at the image on the right. The first character signifies the type of file or directory. Here's a refined breakdown of various types of files and directories you'll encounter in a Linux system. Regular files, represented by a hyphen. These are common in Linux, containing data such as text, programs, or binary information. Directories, represented by a lowercase d. Serving as the backbone of file organization, directories are special files that house references to other files and directories, establishing the file system hierarchy. Symbolic links, represented by a lowercase l, also referred to as soft links. Symbolic links are special files that act as shortcuts or aliases, pointing to other files or directories within the system. Character devices, represented by a lowercase c. These files represent devices that transmit data character by character, encompassing devices like terminals, keyboards, or mice. Block devices, represented by a lowercase b. Reserved for transferring data in fixed-size blocks or chunks, block devices include hard drives, SSDs, and USB drives, among others. Name pipes, represented by a lowercase p. Known as FIFOs, first in, first out, name pipes facilitate inter-processes communication between different processes. And finally, we have Unix domain sockets, represented by a lowercase s. Exclusive to inter-process communication within the same host, Unix domain sockets are special files aiding in seamless data exchange. This comprehensive categorization encompasses the diverse array of files and directories found in Linux, ensuring efficient organization and functionality. Now, transitioning to the next crucial aspect, let's unravel the significance of the next 9 characters. These characters represents the file permissions, complementing our understanding of file types and laying the foundation of comprehending access control within the Linux environment. The next 3 characters are RWX, indicating read, write, and execute permissions, correspond to the file owner's access rights. The subsequent trio represents the access permissions for the group, denoted by the same symbols. Lastly, the final 3 characters denote access permissions for others. Each permission can either be represented by the hyphen, which indicates no permission, or by the corresponding letter R, W, or X. These sections of the permission string RWX specify access rights for different user categories. And that concludes our lecture for file properties. Thank you so much for watching my video. If you have any questions or concerns, feel free to ask in the comment section below. If you found this video helpful, consider dropping a like and subscribe for more Linux content. Thanks again for watching and have a great day.